Hello students, I extend a warm welcome to all to this session. So let us move towards the next point in the revision session. In last video, I explained you rectifier diode. Now I am moving forward towards Zener diode. Okay. So let us start with the symbol. This shows you the symbol of rectifier diode, and as I told you that the diodes can be operated or biased in two ways. First one is known as forward biasing and second one is known as reverse biasing. So according to that, Zener diode always use in reverse biased mode. So what do you mean by reverse bias mode? I am showing here. This is the anode of Zener diode. This is the cathode of Zener diode. The anode terminal of Zener diode is connected to negative terminal of the battery, whereas cathode is connected to the positive terminal of the battery. So it is always used in reverse bias mode. So figure 1 shows you the reverse biasing of Zener diode. So let us move towards the construction of Zener diode. Now it is exactly similar to the construction of any generalized diode. It consists of P and N type material sandwiched with the PN junction layer. Okay, so this is gives you the depletion layer. The width of depletion layer is kept sharp by using any one material heavily doped. Okay. So now I am connecting a battery here in reverse bias mode as shown in figure 1. It gives you the figure 2. Now let us move towards the energy band diagram of Zener diode. So let us move towards the construction of Zener diode. So for that construction I am going to refer the band diagram of Zener diode. So according to that, this gives you the conduction band. Okay. Now, so below that you have the valence band. Here you have the valence band. Now see, this layer provides you p-type material. What do you mean by that? This is the conduction band for p-type material and this is the valence band for p-type material. Similarly, here you have the conduction band for N-type material and this is the valence band for N-type material. So, and between these two, you have the depletion layer. Okay. So, I am going to compare this figure with above one. This is the p-type material which consists of positive charge particle. Here you have this p-type material. This is the N-type material which has the majority charge particle, that is nothing but electrons. So similarly here you have the N-type material. This is the depletion layer. So this provides you the depletion layer. Get it? Okay. Now let us move towards the working principle. All of you know that very well. At 0 degree K, okay, 0 degree Kelvin temperature, the valence band is totally filled with the charge particle. Is it? Okay. So this is the valence band of P type, hence it is totally filled with the charge particle. This is the valence band for N type, so it is also totally filled with the charge particle. But now let us move toward the conduction band. Similar to that, at 0 degree Kelvin temperature, conduction band is totally empty. So this conduction band for P type is totally empty and this is the conduction band for N type. It is also totally empty. You just observe the figure C carefully, or figure 3. Let us label it as figure 3. You just observe this figure 3 carefully. Now, by observing this, what you get noted, this totally filled valence band is appear exactly in front of totally empty conduction band of N type. So what happened? The charge particle from this filled energy level will get jump immediately or easily towards the conduction band of N-type material. So let us take one example. ओके, ते एक्झाम्पल आपण मराठीतून घेऊया. सपोज एक टाकी पूर्ण पाण्याने भरली, आपण वर ठेवली आहे, स्टूलच्या वर ठेवली आहे, ती पूर्णपणे भरती आहे, पाणी चालू आहे त्याच्यात भरणं, आणि खाली बादली ठेवली. टाकी भरल्यानंतर पाणी कशात येईल? ॲटोमॅटिकली टाकीतनं बादलीमध्ये पडेल. का? कारण वरून हायर लेवलपासून लोअर लेवलला पाणी ॲटोमॅटिक येतं. तसंच ह्या ठिकाणी आहे, हे व्हॅलन्स बँड टोटली फिल्ड आहे चार्ज पार्टिकलने. ओके, आणि हा कंडक्शन बँड टोटली एम्प्टी आहे. त्यामुळे हे चार्ज पार्टिकल इझिली कुठे जम्प घेत आहे? कंडक्शन बँडला. म्हणजेच काय? पी टाईपच्या व्हॅलन्स बँडपासून एन टाईपच्या कंडक्शन बँडला ते जम्प घेत आहे. या जम्पिंगला काय म्हणता माहिती आहे का? इट इज नोन ॲज टनेलिंग ऑफ इलेक्ट्रॉन. इज इट? नाउ what happen when one electron tunnel or jumps from valence band to conduction band? It deactivates the another one, so the second electron also take the participation in this jump, and number of electrons will get increase in this tunneling, and large amount of current flows through this Zener diode, because flow of electron is nothing but the current. In this way, when Zener diode is in reverse bias mode, the large amount of current flows. See how does the current flow? Initially, when Zener diode works, the current flows. This is known as reverse current due to the minority charge particles. But when the tunneling of electron starts, there is a sharp current through this Zener diode, and that is known as Zener current, and it will be achieved at the Zener voltage Vz. Okay, as the Zener diode provides you the constant current at constant voltage, Zener diode can be used as a voltage regulator. Get it this? Now let us move towards the second type of diode, and that is nothing but light emitting diode, and you are familiar with this. Okay, that is known as LED. Okay, so now light emitting diode is a diode which emits the light when it is in forward bias mode. You just remember one thing: when diode is in forward bias mode, it will conduct heavily, and when it is in reverse bias, it does not conduct. So LED always used in forward bias mode, then it will conduct and it generates the light. It provides you the light at the output. That is the working principle of LED. So the symbol of LED is like this. As it emits the light, that emission can be shown by these two arrowheads which are in outward directions. Okay, so this is the symbol. Now the construction is like this. Construction कसं आहे बघा, वरचा P टाईप, खालचा N टाईप मटेरियल घेतला, तर N टाईप मटेरियल असं आणि P टाईपला कनेक्टिंग पॉईंट्स आपण असे काढतो. का असे काढतो? कारण ह्या ठिकाणी जेव्हा इलेक्ट्रॉन्स इमिट होतात, ते कुठून इलेक्ट्रॉन्स इमिट कुठून होतील? लाईट कुठून इमिट होईल? N टाईपच्या इथून. मग हे मॅक्सिमम इलेक्ट्रॉन्स जर ह्या पॉझिटिव्ह चार्ज पार्टिकल आहे, ह्या पॉझिटिव्ह पार्टने जर ॲब्झॉर्ब केले तर आउटपुटला काहीच लाईट जाणार नाही. म्हणून पॉझिटिव्ह पार्टचे जे कनेक्टर्स आहेत ते मिनिमम घेतले, कारण मिनिमम ॲब्झॉर्प्शन होईल इलेक्ट्रॉनचं आणि मॅक्सिमम लाईट कुठे जाईल? आउटपुटला जाईल. सो दिस इज वॉट द कन्स्ट्रक्शन ऑफ लाईट इमिटिंग डायोड. Okay, now let us move towards the construction of LED. So LED can be constructed by using different materials like silicon carbide. Okay, so now let us see the working principle. What happened? As I told you, this is what conduction band and this is what valence band. Valence band is totally filled with the charged particle at 0 degree K, but conduction band is totally empty. In general diode, what happens when electron jumps towards the conduction band, the current flows through the diode. That is forward action of the diode. But what happens if the electrons is jump from higher energy level to lower energy level? What happens? They have the extra energy, and that extra energy can be released in the form of temperature in case of normalized diode. But in case of light emitting diode, this extra energy can be emits in the form of light. Why? Again I am going to repeat that when any charged particle will jump from higher energy level to lower energy level, they have the extra energy, and that energy can be released in the form of temperature in normal diode and in the form of light in light emitting diode. In this way, when light emitting diode is in forward bias mode, it emits the light. So for the today's session, let us stop now. In next session, I am going to explain you the application of diode. Still then, let us stop.